In last session, we have learned what are sets and their representations and also type of sets. Now let us learn about operation on sets and Venn diagram. Before going to operation on sets, let us know what are Venn diagrams. Most of the relationship between sets can be represented by means of diagram which are known as Venn diagram. This diagram consists of a rectangle and closed curve, usually circle. Universal set is represented usually by rectangle. This rectangle is a universal set and it's subset by circles. In Venn diagram, the elements of sets are in their respective circle. Like if the element of the set is 1, 2, 3, we will write 1, 2, 3 in this circle. This represent the Venn diagram. Now let us move on to operation on sets. The first is the union of set. In earlier classes, we have learned how to perform the operation of addition, subtraction, multiplication, division on numbers. Each one of performed on a pair of numbers to get another number. We will now define certain operation on sets and examine their properties. That is the operation on sets. Union on sets. Union of set. It is generally represented using the symbol U. U used to denote the union here. U is used to denote the union. It is represented like this. And it is, if it is a two set, we will write A union B. We'll write A union B. It represent the two sets A union B. When let A and B any two set. For example, it is given here A and B be the two set. If the set A contain 2, 4, 6, 8 element and B contains 6, 8, 10, 12. Let us take this example. What is union of set? The union of A and B is the set which consists of all the elements of A and all the elements of B. The common element is being taken only once. It is the element from A and element from B, but the common element is taken only once. Now I can say A union B is equals 2, 4, 2, 4, 6, 8, 10, 12. I have taken all the element of A and all the element of B, but the repeated term, the common term is taken only once. That is the union of set. Union of set. Union of sets can be represented by Venn diagram as shown in this figure. It represented by the Venn diagram. The shaded portion, the yellow shaded portion, it represents the A union B. Yellow shaded portion is shown the A union B. Now let us move on to some of the properties of the union of set. Some of the properties of union of the set, that is commutative law, associative law, law of identity, idempotent law. That is A union B is equals B union A. It is the commutative law. If you come to the associative law, you will get the three set there. That is A union B, union C, A union B union C. And the law of identity and a idempotent law. Idempotent law, A union A is equals, A will get the same set A. U union A. U is what? U is a universal set. U is a universal set. U union A, you will get universal set itself. It is called the law of U. Now let us move on to the intersection part. The intersection of set A and B is the set of all the elements which are common to both A and B. Before that, what is the symbol to represent the intersection? Intersection is, in this we will represent the intersection, whereas the union will write as U. The symbol intersection is used to denote this intersection. And if I take the example A, E, I, O, U and B is A, I, U, how you will write A intersection B? What is the definition of the intersection? The intersection of the sets A and B is the set of all the elements which are common to both, A and B. Which are the letters that is common to both A and B? Then I will write A intersection B is equals A, I, U, right? This is the common to both the set, that is A, I, U. It is a intersection. Intersection means intersection of the set A and B is the set of all the elements which are common to both A and B. The intersection of the set can be represented by Venn diagram as shown in this figure. Intersection. The shaded portion in dark color represented A intersection B. It is clearly shown here. It is the intersection part. Intersection is the common to both A and B. That is A, I, U. Now let us move on to the properties of operation on intersection. Same as in the union, properties, that is commutative law, associative law, law of identity, idempotent law, and the distributive law is mentioned here. Distributive law, that is A intersection B is equals B intersection A, that is commutative law. A intersection B intersection C, that is equal A intersection of B intersection C is the associative law. Whereas the law of identity is given, universal intersection A is equals the set A. Idempotent law, we know that A intersection A is always the set A, and the distributive law is the A intersection B union C is equals A intersection B union of A intersection C. It is a distributive over U. Now let us see difference of set. The difference of the set A and B in this order is the set of element which belongs to A but not to B. Which belongs to A but not to B. Symbolically we will write A minus B. It is a difference sign. We know that difference sign is, that is minus. We read as A minus B. It is a difference of set. For example, if I take 1, 2, 3, 4, 5, 6, B is equals 2, 4, 6, 8. Find A difference, that is A will read as A minus B or B minus A. How we'll see what is A minus B here. A minus B. Difference of set. We have A minus B is 1, 3, 5. That is 1, 3, 5. Which is not present in B. The element which is not present in B but present in A. Which is the number present in A, that is 1, 3, 5. A minus B is 1, 3, 5. 2, 4, 2 and 2 is, it will get vanish, 4, 6 and 6. It is remaining A minus B is 1, 3, 5. If I say what is B minus A, what you will write? B minus A, 2, 4, 6, 8. The element that is present in B but not in A, that is, will get 8. Since the element 8 belongs to B and not to A, we note that. What we note that A minus B is not equals B minus A. The Venn diagram of the different set is given here. The difference of two set is A minus B. A minus B means we will get A. How we will get A? It is clearly mentioned here, 1, 3, 5. That is the only element present in A. Only element present in A. Now let us move on to the next complement of set. What is a complement of set? Complement of set A contains the element present in universal set but not in the set A. It is contained in the example of a complement set. It is given here. A is equals 1, 2, 3, 4. U is 1, 2, 3, 4, 5, 6, 7, 8. Then find A complement. Then I will write, it is not present in the set but in the universal set. What is the 1, 2, 3, 4? We will write 5, 6, 7, 8. That is A complement. And some of the properties of the complement set is given. De Morgan's law, law of double complementation, law of empty set. De Morgan's law is a complement of the union of set in the intersection of their complement, and the complement of the intersection of two sets in the union complements. These are called De Morgan's law, and the Venn diagram of complement A and complement B is clearly shown here. These are the operation on sets. Now some of the CET question is given here. The set of intelligent students in a class, that is, one is null set, singleton set, finite set, and it is not a well defined. Intelligent is not defined for student in a class, that is, it is not well defined. And second is, which of the following is the empty set? In this, X is not A, the answer will be the D. Why? Because X is not a real number, but X is a real number is given. Therefore, no value of X is possible. The next is the set X such that X belongs to R. X square is equals 16 and 2X is equals 6. If X square is equals 16, what is X? You will get X plus or minus 4. 2X is equals 6. 2X is, there is no value of X which satisfy both the above. So the answer will be A, that is null set. Thank you.